Astronomers have discovered the largest ever collision of binary black holes happened 9 billion years ago. It was one of the most cataclysmic events in the universe and was detected from wrinkles in space and time, known as gravitational waves. The celestial impact formed a new supermassive black hole about 80 times larger than the Sun. It happened 9 billion years ago, but the ripples only made it to Earth last year, and was undiscovered until this year. The detection of the huge event was enabled by the Advanced Laser Interferometer Gravitational Wave Observatory, LIGO. The collision's gravitational waves were detected after passing through Earth on July 29 last year. Detection of the principal wave was then followed by signs of 3 smaller black hole mergers in August. It brings the total number of black hole merger detections to 10, along with a neutron star collision, during the past 3 years. An international team, led by dozens of Austrian astronomers, have detected the event, and Professor Susan Scott says she has spent most of her career hoping to detect such gravitational waves. She said that technology advancements were finally giving scientists answers. This event also had black holes spinning, the fastest of all mergers observed so far, and it is the most distant merger in the universe ever observed, Professor Scott said. "We can't see these events any other way except through gravitational waves, as they don't emit light or radio waves, because they're black holes," she said. The binary systems, meaning 2 black holes orbiting each other, eventually smash together and radiate strong gravitational waves, which are very faint by the time they reach Earth, said Professor Scott, from the Australian Research Council Centre of Excellence for Gravitational Wave Discovery. The detections will improve scientists' understanding of how many binary black hole systems there are in the universe, and the range of their masses, and how fast they spin during a merger, she said. Researchers plan to use LIGO's technology to detect cataclysmic events even further out in space, in the hopes they can reach back to the beginning of time. The next observation run to collect data will begin early next year, following work to make the gravitational wave detector more sensitive. Professor Scott will present the recent results at the Australian Institute of Physics Congress in Perth later this month. "This should be the biggest announcement at the whole Congress. It's a pinnacle of my career," she added. Dr. Carl Wett, a postdoctoral fellow in the group at ANU and a member of OzGrav, said scientists were not sure what was formed from the neutron star merger that was detected in August last year. It could have been a neutron star that collapsed to a black hole after some time or turned immediately into a black hole, he said. "Our new project will help to provide critical information about what we get from the merger of 2 neutron stars. The results of the discoveries will be published in Physical Review X."